Europa is the size of Earth's moon. It is covered in ice. And for most of the 20th century, scientists looked at it and saw nothing. A frozen rock, tidally locked, bathed in Jupiter's radiation. Geologically simple. Dead. That was the consensus. That was the comfortable answer. And for decades, no one looked closely enough to know they were wrong. But here's what that actually means. Beneath that ice, beneath hundreds of kilometers of frozen silence, there is a liquid ocean. Not a pocket, not a trace. A global ocean, larger by volume than every ocean on Earth combined, pressing against the underside of the crust from below. It has been there for billions of years. In the dark, in the heat of tidal flexing, in complete isolation from the sun. And something has been keeping it warm. Let's be precise about this. Europa orbits Jupiter. Jupiter is massive, so massive that its gravity pulls Europa slightly out of shape with every orbit. The moon stretches. It compresses. That mechanical stress generates heat. Not enough to melt surface ice, but enough, just enough, to keep a liquid ocean alive in the permanent dark of the outer solar system. Scientists knew this for decades. They modeled it. They published it. They were cautious about what it meant. Then Galileo flew past Europa in the 1990s, and the magnetic field data came back wrong. Not broken, wrong in a specific way. The kind of wrong that only makes sense if there is a saltwater conductor beneath the surface. The kind of wrong that means the ocean isn't theoretical anymore. It's there. But here's the problem. An ocean is not life. Water is not life. Heat is not life. The universe is full of warm water in dark places, and the answer has always been nothing. So Europa was catalogued, studied, prioritized for future missions. And the scientific community agreed on a careful, measured position, promising, but unconfirmed. That was the position in 2022. And then something happened. The James Webb Space Telescope was not designed to look at Europa. Its primary mission is deep time, galaxies at the edge of the observable universe. The first light after the Big Bang. The atmospheric signatures of distant exoplanets. But Webb sees in infrared, and infrared sees heat. And in 2023, Webb turned toward Jupiter's system and captured something in Europa's spectrum that no one had predicted. Carbon dioxide, concentrated, localized, on the surface, not distributed evenly, the way you'd expect if it came from space, from cometary bombardment, from external sources, concentrated in a specific region, a region called Terra Regio. And that changes everything. Here's what that actually means. Carbon dioxide doesn't stay on Europa's surface. Jupiter's radiation bombardment destroys surface chemistry aggressively and constantly. Whatever is sitting in Terra Regio, it is new. It was not there long ago in geological terms. It arrived recently, and it didn't come from space. The only coherent explanation is that it came from below, from the ocean. Something in that ocean, some chemical process, some geological activity, some biological or pre-biological reaction pushed carbon dioxide up through the ice, through cracks in the crust, and deposited it on the surface where Webb could see it. The ocean is not sealed off. It is communicating with the surface. Let's be precise about this. Carbon is one of the fundamental building blocks of life as we understand it. Not because we decided that arbitrarily, because carbon forms more molecular bonds than any other element. It chains, it branches, it builds complexity in ways that silicon and nitrogen and oxygen alone cannot. Every living thing that has ever existed on Earth is a carbon-based structure. The ocean beneath Europa's ice contains carbon, in solution, cycling, moving, and it has been doing this for potentially 4 billion years. But here's the problem. Carbon dioxide alone proves nothing. Hydrothermal activity can produce carbon compounds without biology. Serpentinization, a geological process where water reacts with certain rock types, can generate organic molecules with no life involved whatsoever. Scientists are careful here. They have to be. The history of astrobiology is littered with premature announcements. Martian meteorite ALH8 for 001 in 1996, phosphine in Venus's atmosphere in 2020. Each time, the signal was real. the interpretation required revision. So carbon dioxide on Europa is not a detection of life. It is a detection of chemistry. Active, recent, sourced from below. And that is almost as significant. Because here's what active ocean chemistry means for Europa specifically. On Earth, life did not begin in sunlight. The oldest evidence of life on this planet points toward hydrothermal vents, cracks in the ocean floor where superheated, mineral-rich water meets cold deep ocean. No sunlight, no photosynthesis, complete chemical darkness. And yet, life, entire ecosystems built on chemical energy alone. Tube forms, shrimp, microbial mats. A complete biological food chain with no reference to the sun whatsoever. If that happened on Earth, if life bootstrapped itself in a dark, pressurized, chemically active ocean, then what exactly is the argument that it couldn't happen in Europa's ocean? The ocean is larger. The chemistry is active. The timeline is longer. The argument gets harder to make. And then something happened. Webb's carbon dioxide detection was significant, but it was accompanied by something the team did not immediately publicize. A second spectral signature, faint, ambiguous, requiring confirmation. Hydrogen peroxide. On Europa's surface, hydrogen peroxide is generated constantly by radiation breaking apart water ice. That's known. That's expected. But hydrogen peroxide is also a chemical oxidant. It stores chemical energy that, if it migrated downward into the ocean through surface recycling, would create the kind of electrochemical gradient that drives metabolism. On Earth, oxidants and reductants meeting across a gradient is one of the foundational mechanisms of cellular energy. If oxidants from the surface are reaching the ocean below, and if the ocean floor hosts hydrothermal vents producing reductants from below, then Europa's ocean may have both sides of the electrochemical equation running simultaneously. That is not just promising. That is a working energy system. Let's be precise about this. Life, at its most stripped down, is a chemical reaction that refuses to stop. It takes in energy. It maintains itself against entropy. It makes copies. For that to begin, you need a source of energy, a medium for chemistry, and time. Europa has all three. It has had all three for longer than complex life has existed on Earth. And no one has been looking at it. Not really. Not with the instruments that could tell us something. Until now. But here's the problem. We cannot confirm any of this without going there. Webb sees in spectrum. It tells us what molecules are present at the surface. It cannot image the ocean. It cannot sample the ice. It cannot reach the vents. For that, you need a spacecraft in orbit. You need a lander. You need, eventually, a probe capable of penetrating kilometers of ice to reach water. NASA's Europa Clipper launched in October 2024. It will arrive at Jupiter in 2030. It will conduct 49 flybys of Europa over 4 years, mapping the surface, analyzing the magnetic field, characterizing the ice shell, searching for plumes. Plumes, because Webb also detected, tentatively, still under analysis, what may be water vapor activity above Europa's southern hemisphere. Geysers, perhaps. The ocean venting directly into space. If that is confirmed, Europa Clipper will fly through the plume, and it will taste the ocean without ever touching the surface. And that's where it gets strange. If a plume exists, if Europa's ocean is actively venting water, vapor into space, then the ocean is not sealed. It has been broadcasting its chemistry into the Jupiter system for potentially millions of years. We have been inside the solar system the entire time. We have probes that passed through this region decades ago. And we were not looking for this. We were not equipped to find it. The signals were there, and we had no instrument sensitive enough to read them. Webb changed that. Webb looked at Europa for a few hours and found evidence of a chemically active ocean communicating with its surface. One telescope, a few hours, 4 billion years of chemistry finally visible. Here's what that actually means, not for science, but for you. Every definition of habitable zone ever written placed it around a star. The right distance, the right temperature, liquid water on the surface, warmed by sunlight. That definition assumed life needs the sun. Europa does not have the sun. Europa is 628 million kilometers from the sun. At that distance, Sunlight is 25 times weaker than at Earth. The surface is negative 160 degrees Celsius, and it may have an ocean full of chemistry that has been running for 4 billion years. If life exists there, if it exists in any form, microbial, chemical, ancestral, then the habitable zone is not a ring around a star. It is everywhere there is liquid water and energy. And liquid water and energy exist throughout the solar system, Enceladus, Titan, Ganymede, Callisto, potentially, Ceres, potentially, Pluto's subsurface. The habitable zone is not a location. It is a condition. And that condition appears to be far more common than anyone modeled. But here's the problem. We have not found life. Webb found carbon. It found chemistry. It found an ocean that is not sealed and not dead. It did not find biology. And the distance between chemistry and biology is the most important distance in the history of science, because we have crossed it exactly once on exactly one planet, and we still don't fully understand how. So Europa sits there, 628 million kilometers away, covered in ice, bathed in radiation, its ocean pressing against the underside of the crust in the dark, running its chemistry in silence. For 4 billion years, it has been doing this without an audience. We are the first audience it has ever had, and we've only just learned to listen. Europa Clipper will reach Jupiter in 2030. It will spend years mapping a moon we thought was dead. Whatever it finds, life, or the conditions that precede life, or the conditions that make life inevitable, or nothing at all, the answer will arrive in our lifetime. For the first time in human history, we are close enough to the question to hear it. We just don't know yet what the ocean is saying.